I was asked to talk about the fourth industrial revolution, but I'll choose only a slice of it, for example. So we've got, all the other industrial revolutions that come before, all the way from mechanization, mass production. I think that most of us here are connected with is computing and automation that's allowed us to be where we are today. And then now there's these cyber-physical systems that are coming along. And now we are at this point where you have all these emerging technologies that are connected with the fourth industrial revolution. And there's parts where it's amalgamations, some they're new, and we're trying to now deal with how the heck do we see our near future. It's no longer very far in terms of how we're going to develop as a continent. So for myself, I'm in robotics, AI, artificial intelligence, and autonomous vehicles are the spaces I'm comfortable with just because of my background. So I can talk to any of those. I don't do really much IoT at the university, but I do it at home. So it's a hobby. I build things that need to be connected to the internet that sometimes are very stupid, but they show these promises on there. And then the rest are just spaces I've been around over the last 10 or so years, kind of in a specific. So again, I state my bias at the beginning. So one of the questions that comes up is, but what's this data science thing? That everybody's telling us there's data, there's all these things that we have to do, but nobody's telling us what actually this thing is, right? But we're being told we must jump onto this. So there's this Venn diagram that normally shows up, and I think for me it's very true on this part, is that you have expertise, like people as yourselves in this room, in the specific parts of science that you represent. You have people then who also have math and statistics knowledge, and when you put it together with some hacking skills, and not hacking in the negative, hacking is actually a positive word, it's just you look at something and you try to break it and figure out how you can improve it in a way. When those three things kind of come together, you get data science. So for me, when I was doing my PhD, I found it very hard to wake up in the morning and go I want to go do, what is this, theoretical machine learning. It just didn't, but I was very interested in actually putting these things together. How do I go work in something like health, use machine learning, AI, build up the theory if required, then actually solve a problem that is in the world out there. And to do that, I needed all these pieces, and I started identifying more and more with the data science subculture in a way. The easiest way, I think, to maybe translate it to here is that we can look at it as a pipeline that comes, some parts of it from the data mining literature, where you're going to have, as you're doing your science, you acquire data, you're going to process it, you're going to integrate different pieces of data, analytical modeling, which most of you, if not all, do this analytical analysis, modeling of processes that are out there, you validate and you present. For me, normally I don't like this piece as just being called presentation, just because we want to then talk about translation, you deploy. It goes out of your hands. It is no longer something that is just built for you. You wrote a nice paper, people thought you were great about it, but who cares? All right, so there's this deploy thing because then you hand it over to somebody else who's not you, and they have to use it now in their delivery of services, in changing the way that they work, in improving lives, kind of in a way. So for me, this is the whole kind of data science process on there. So again, then you have to take one more step back and say, people again saying, okay, there's AI, there's machine learning. What are all these things, in a part? So, classical definition of AI, artificial intelligence is an agent. It exists in some environment to take action and achieve some goal. So the example I give sometimes is you've got Google, it's got a little search bar, it exists on the internet on there as it is environment. The action that it takes is that when you type in a search query, it has to go search through its databases, and then it responds. And the way it responds is that it's trying to increase the chances that its results meet your query, right? That's the goal. That's AI. All right, you're going to hear a lot of things out there and things like that. This is AI. Right, on there. That's the classical definition on there. And the thing that you'll hear also with this is machine learning. So again, you're going to come out and say, what's machine learning? Machine learning is a subset of artificial intelligence that deals with how do you learn patterns from data. So how do you get to data, from data to patterns? Why is this important? So for example, I give this simple example where you have two data points that you see on a plane. And then the machine says, oh, each of them have a different label. One is white and the other one is black. I can learn a decision boundary. And in the future, anything that shows up on the left, I'm going to mark as being white, even if I don't know what it is. And anything that comes on the right, I'm going to mark as being black, because now I've learned this decision boundary and that part, right? So I've learned that pattern. You can make this more complicated. And let's say now we have these two pieces of data. And now your decision boundary, instead of being very nicely linear, becomes a little bit more complex, right? But then there, you've already learned that pattern. That where now when new data comes in and let's say a dot shows up here, you're just going to mark it as black. And if a dot shows up here, you're going to mark it as being white. And this kind of now brings up to where we are in machine learning today. Is just that these models are just much more complex, but you build up that complexity, and at the end of the day, you can put in a picture on there, and then this model then infers that, hey, at the end of it, that's actually a dog and not a cat. Right? Right? All right, yeah. You see? Yeah, on that part, but that's what deep learning is, which is the other moniker that you hear probably these days. And this is augmenting our lives, right? Every day, whether you are coming here and you are using a service like Google Maps or Uber, or you're listening to music, watching movies, all these things, all these systems behind them is they're using these machine learning tools to learn patterns about you, to figure out what you might like watching, what you might like listening to, what's the traffic like in Nairobi, very important, in a way, and predicting all those things, it's machine learning. All right, so we're in this part where it's no longer a thing that we're thinking about. We are going, it is in our lives. You are part machine now because you have now offloaded some of your own mental processing to these machines that are doing processing for you. And how can this also be, if we're very optimistic, on the continent? For example, some work from Makerere in Uganda. People are building models where you can take pictures with your cell phone of cassava leaves, and then from there actually diagnose what kind of diseases they might have. So think about this now, again, in the hand of somebody you deploy. It's in the hand of a farmer now, and the farmer can now use this tool to do that. So much better than figuring out if it's a dog or cat. Now you can figure out disease. Right, on that part. For example, this was some work by a colleague at the CSR in South Africa where they're looking at drowsiness detection in a car. So you can think about fleets and people who drive for a long period of time, trucks and those things where you can identify if somebody might be drowsy. This on the right is some work that I did with a student on looking at road traffic accidents in South Africa. And if we could figure out, if we learn from patterns, can we now move these patterns across the country and then assist in better planning for towns or augmentations of towns so you can reduce these accidents. So my group at the University of Pretoria works at this intersection of you have data science for society. So I care about the deploy part. How do I end up with the thing that I'm actually doing my science on being in somebody else's hand? And then also this natural language processing and machine learning. So our projects fall normally within these two spaces, and then some of them do kind of overlap in some ways. Just to highlight one project, sorry, just checking on my time. For example, this is we were working with the government of Sierra Leone on trying to extract what are the factors that impact education quality in a country. So you get some data that you put as input. This one was South Africa, so you can look at all those schools, and some of them are low performing, some are high performing, and on there we then use machine learning tools to be able to extract these features. And our next part then is to work with DSTI, the Directorate for Science, Technology, Innovation in Sierra Leone, and we're trying to now look at the Sierra Leone situation and compare it and contrast it to South Africa, kind of in a way, and see actually, could we then end up with a tool that we give to decision makers about how to make these decisions, about funding of education. This is a project now, hopefully gets accepted. I've been going through some reviews and for a journal, and this is now saying, hey, we've all gone online, we chat and all those things, and there's challenges with cyber safety. In this one, we're looking at sexual predators. Can we build systems, and do some research work that can assist us in identifying whether a conversation online might be between a child and a sexual predator, and at the same time, can we then highlight likely where the evidence lies for a person who works in law enforcement? They're not a machine learning expert, so telling them that this conversation is between a child and a sexual predator is not enough. Right? You now have to do these other parts that need you, that get us closer to that translation, right? Of saying this now will be important for law enforcement, in a way. Right, so yes, hey, great, we can solve these very interesting problems, but what are the challenges in doing this mission? So we go back to this pipeline, and I think it was said earlier, problems start showing up. Where's the data coming from? And then two, how do we get to the societal impact? I did tell you, it seemed I'm at the right place. On the how do you do this translation becomes another part that you need to take care of. You can't just talk about it. In a way, in your last paragraph of your report, that this could be useful. But how do you actually get that to be useful as part of this thing? So on the societal impact side, I want to highlight some challenges and maybe some heuristics. So one is the long tail. There is a long tail, a long period sometimes between an innovation and when it actually makes sense inside society. So we have to also accept this. It's not that you do your research and then it automatically will be translatable, but we have to think about it. And we have to think of ways to actually nurture that and encourage that even the long tail itself will be actually rewarded. Assigning credit. So when you're working in these multidisciplinary teams, people are doing very different things. And because you have these different parts of science, sometimes it's like, how do you assign credit that this person did that and then that person did that, given that in my area, people don't normally do this, right? And so we still have to think about these challenges and how to fix them. Getting funding. Now you're going to fund, you know how to do things well in math, but then now you want to fund a project that has a mathematician and a biologist. And then it's like, oh, but we really want to do the biology also as well. So can we get that to be covered as a whole as opposed into these pieces? And data is about people, which I'll then, I think that'll be a bit of a big part of the rest of the presentation on there. Okay, so having impact is thinking about sometimes very long-term horizons, maybe more than 3 years, maybe more than 2 years, maybe more than 1 year, depending on where you are. I worked during my time outside the academy, I worked with governments. And sometimes having to think with a local government over an 8-month period was tough, to think beyond that, right? But then you're trying to make impact, right? But nobody wants to think more than 8 months, or nobody wants to think about the second half of the financial year, right? I worked in spaces where sometimes, everything is very active in the last 3 months of the financial year because people have to get rid of money. Right? These are realities. But then now you're like, I need to do science in this space, and I need to get it out into the right people so they can make the right impact. All right? But then we need long tail. Right? And sometimes it's worthwhile, because if you're thinking in this way, there's still ideas for me for 4 years, 5 years ago that now are becoming more fruitful in the way that I think of them, because I'm matured as a scientist. I've learned how to now navigate some of these situations, whether it be scientific, some industrial, some political, in getting these going. And that's the history that you, the experience that you get for working with different organizations, instead of just staying within one area that you're very comfortable with. And at the end, I think also innovation is also making sure you empower people to take charge of, at the end, what that innovation is going to be. I know, as a scientist, you get to the point where you go like, I think this is enough for me, and you go, but then you want it to live on at the end of the day, because unless you're going to change, and that becomes your job. It's a team sport. We've talked about transdisciplinary work, but you need the right people and also at the right time. So sometimes you might get people, and then it's just not the right time for it to go. It is okay to think about, maybe we'll reassemble in 6 months, but not right now, just because things aren't working out in the way that we want. We want to have this data dividend. Right? Everybody's saying there's data, it's very important for us to have, and we want to be able to reap it. The other one is that we want to reap this youth dividend that we have on the continent. which again, like the previous speaker talked about. But we have to think about it. You can't just go and state it without figuring out how we actually tap into these two things in a way. And we also need to compromise on the incentives. So if you're doing these projects, it's not that at the end of the day, it's only your incentives. The reason I do say this, my PhD was on a subfield of machine learning called reinforcement learning, where you basically teach machines to optimize, to learn about metrics. And for me, I see the world in that way. Everybody in here, in one way or another, has an incentive scheme that's in their brain. They do work in a way, because of the way that the systems are set up, to try and optimize for those incentive schemes. And if you're sitting around a room with other scientists who are working in different fields and you're trying to work together, you have to kind of figure out, maybe I'll take 70% of my normal incentive scheme so that I can bring yours in so that we can actually finish this project in the way that it's going to make impact, right? So you have to learn that that's a compromise that becomes part of that thing, right? So modern science is a team sport, and we need to make also incentive systems in science recognize dynamic credit assignment, that it might change as the project kind of goes on, right? It's not necessarily the same at the beginning. And choosing metrics, one way or another, they're always just the best that we have at the time. It doesn't mean that they're correct, right? It's just that we choose something that might be simpler just because that's the thing that we think we're going to reward for now. But we might learn something down this road and then adjust. We can't stick to it just because it is the thing that we've used in the past. Right, especially in this new world and kind of anyway. So we've talked kind of a little bit of the problems on this side. I wanted to spend the next 5 minutes on this, on the data trouble side. Yeah, so just a few notes about this section. It's a warning. Hopefully it's not like a trigger warning about just some of the things that happen with data. But one of the things that happens is that every time we have these new technologies, especially like in AI, people tell us oh, machines are going to kill us in a way, but then people who live in the spaces, it's not the same way we view it, right? At the end of for most of the time, the machines aren't doing that, very fickle, kind of in a way. How do I highlight this? So this is a picture that came from the AAS website. And that's the machine, and the machine classified the lady as a prophetess. Right. All right, so you can see there a woman prophet. Right? Maybe it's true, prophet of science. Right, and then I went to the AAS Twitter profile, and then I took that picture, and I sort of said, warning, I put it through this machine learning algorithm, and that's what it labeled people as. Okay. So I'll make it look a little bit better. So I'm sorry for whoever that is. That's the Jazan, the jihadist. Okay. So what is this? It's something called ImageNet Roulette. ImageNet is a famous data set that was released in machine learning a few years back to allow people who are working in machine learning to now build algorithms that can then look at pictures and then tag things inside there. But this data set was created also with using tagging from WordNet. WordNet is another database that basically gives linguistic features of words and all those things, and inside there, that's why it goes and it gives you all these little tags kind of inside there. So this is what they're giving the machine. And the machine, you see the results. All right? And this is very recent, this website being created. This is in the last 2 weeks. And it's created a whole crazy storm in the machine learning and AI community. Because now we started noticing that the machines, in this case, are taking this data, which data is never unbiased. It is biased in a way, and then spitting this out. Right, so you can already see the problems that are in there, and it's the work of Kate Crawford in terms of the website itself with an artist on there, and this paper has been cited almost 13,000 times in terms of the one that created this data set. So that shows you how many people are using this data set to train the machines, especially to train them for other use cases, not the original. And that's what it actually did, is that in the last 2 days, 600,000 of them had been, from the data set, had been removed now. Because of this data set, it's been, I think, 5 or 6 years. It's in any machine learning algorithm likely that does image processing today in the world is likely using this data set to train the machine. Right, so it comes up to these things that we're asking the right questions in society about this. This example, I'm going to move a little bit faster through it. Johannesburg now in South Africa said, hey, we have a crime problem. We're going to put these CCTV cameras that have AI or machine learning in them to identify suspicious behavior, right? They've trumpeted it out. Here in Nairobi, you have those nice cameras all over that flash. First time I was coming here in 2016, seeing them at night from Jomo Kenyatta. I was like, what is that in the horizon? Because you literally see them on there. Like, yeah, oh, we have these very advanced systems that are kind of in there. Then you ask yourself, like, what actually could go wrong in these systems? And this is the work of Joy Blomier, who's at MIT, looking at these things, say, like, we should start asking a little bit more questions about these tools and where you go. Here's just an example of trying to figure out, the accuracy of these models and where they see the biggest errors are with darker females, if you're trying to use them for identification, right? And this one, this example, they try to figure out if these different off-the-shelf systems that are coming from companies like IBM, Amazon, Microsoft, if they could figure out if, a face in the picture, the gender, and likely the age range. If it's red, it means that that algorithm got it wrong. So you can see now from the lady from Zimbabwe how much the error is kind of in there. So you have to think about these kind of spaces of the data is it is not going to save us in a way. And what are the consequences? You have companies like these, HireVue, which says now for companies, it will give them analytics whether a person will be a good fit for their company or not by looking at that video. Okay, so, and this is just now talking about, I'm pretty sure for the Africans who are here, your governments, private industries are using these in different ways on there. Now you ask yourself, what's actually going on in these spaces, right? And this now brings me to surveillance capitalism. Running out. So you have to think about this in a way. You have an internet company, that's you on the one side, and then you have this free service that normally is exchange for personal data. In a way, so wait, if you get a free service and then all you have to do is exchange personal data, what is actually going on, right? How does a company make money? And the way that they do is that you're not the client. You think you're the client, but you're not. The client is another company, and then for them, they exchange money for your personal data, right? And that's what we call surveillance capitalism, right? And the thing that happens is that you sign up for a service, and you never read that, and you just accept. Right? And then the services all are crunching, they're doing machine learning, all those things, and to improve all of these things, they have to show ads, they have to show all these things, and they need to improve. And what this also then gets us is that we get to this point where we now have these systems that are built to classify. We've had a very unfortunate few weeks in South Africa through xenophobic attacks, and during that time, what we're also trying to deal with how our society is really reacting to this part. You then also have to deal that there's social media, and these social media algorithms are amplifying things that they think are going to get people to click more, to stay more. And then that's what happened, that you now had all these fake news but clips actually spreading through, people now being like, there's a real problem that South Africa has. There's no skirting around that. But at the same time now, the conversation switches to information that's completely false. Right? And now, but it's being spread by Facebook, by Twitter, by ... because those algorithms, not people sitting and choosing and saying this is going to be amplified on that part. right? Because for them, that's how they make their money on that part. So that's another thing we need to get into. So the point is, as we're doing this data science and this work, we need to also think about these societal impacts, and that's where we need people even from the social sciences. We need to understand our world, understand ourselves, and then shape this evolution of the revolution. Right, that's the kind of my call to action, my first one in here. I'm gonna try and rush up right now. So we must find a way, given what we're doing, to look after each other as though we're single child. Do get it that we have all the different parts of the continent in all these ways, but this is the time we have to come together because we have to have one voice, especially in this area of kind of where data is going. It cannot be something we just co-opt. We have our own values, they're different, we understand that, but we need to figure out ways to get this kind of to go. Where to from here? In this data science for site area, right? For me, I like this quotation. We are the ones we've been waiting for. Nobody's coming. Hoping that somebody else will solve this is not going to go. So we still need to do excellent science. We need to do data curation and sharing. We don't have enough data sets on the continent for a lot of things. We need to do skill building, cross-disciplinary research, and we need to have distributed research innovations, right? And we also have to recognize centers of excellence to keep it going and get the mentorship kind of going. For me, I'm open to chat over the next few days. I just need to push this last piece, hopefully give me 4 minutes to try and get this one. So for us, in thinking, encapsulating all of this, there was an idea that we had a few years ago, and this was the deep learning Indaba. What is deep learning Indaba? So deep learning Indaba was created to strengthen African machine learning. So the vision was that Africans should become critical contributors, owners, and shapers of the coming advances in AI and machine learning. As I said, we can't just co-opt. Hopefully I've made the case why we can't just co-opt these systems anyway. So we started in 2017. We were at VETS in Johannesburg. Initially, we thought we were going to only get 50 people at a workshop, a small thing, and then we ended up having to do 300 people in 2017. Right? And this was just from no major backing from anybody. It was just a couple of us, I think 6 at the beginning, who said, let's do this, and we just started it going. So we had 300 people in machine learning coming to, I think at that year it was like 12 African countries at VETS. 2018 we went to Stellenbosch where we doubled to 600 people at this meeting. And now in 2019, about a month ago exactly, we were here in Nairobi, also with 650. And we also created this new system called the Indaba X system. So in between the major conferences, we also have small ones that happen at the first part of the year. And with that one, in the first year, we did 13 countries having 1 or 2 day workshops, and we reached 1,000 people across 13 African countries. So already more than what we can do in the single meeting that we have during the year. This is very important. And for this year, for Indaba X 2019, we did 27 African countries between March and May, with people just doing 1 or 2 day workshops in this space, building up to the main conference, which was here in Nairobi in August. Anyway, and there's also a local community network of people who are working in machine learning, data science, mathematics, in these kind of spaces. So this is real, right? Sometimes we talk about it, and people don't understand until they've been to it in Indaba. It is not just, oh, we're sitting there doing a talk shop, right? People critically engage on what is actually going on in machine learning on the continent. We have both trying to teach and at the same time bring people into machine learning, data science, and AI who in the top flight of this scientific area, they're not represented. And kind of in a way, teaching is also serious. We literally, if we have 650 people at the conference, we also have labs that fit 650 people for teaching. In a way, and there's been great collaborations that are going in through there. And also, same thing, we have a poster session. Now, initially, we just had a poster session in the evening. Now we have a whole research day as part of the whole 5 or 6 day kind of conference. And we have partnerships. So this was a partnership with UNESCO, looking at the ethical challenges that have to do with artificial intelligence. And again, driven by Africans. Right? From the whole program is from the ground up. Actually started in Africa for us. In a way, as I said, we were here in Nairobi in August, and we are moving to Tunisia next year. There, and hopefully some of you will join us in that part. Impact has been across We got now Latin America is starting their own program. That's this November, inspired by the Indaba over the last 2 years. And Southeast Asia just had their own one in July, again inspired by the Indaba here on the African continent. As I said, African continent will be the one that's moving us to this next kind of piece. Google started their new lab, their first engineering lab on the continent. Google, Facebook, whoever, they have presence on the African continent, but it's all business. Remember, surveillance capitalism. They're not doing the engineering, they're not doing the science here. So Google has their first lab now in Accra that actually does the science. In this space, on their announcement of this lab, the Indaba was also mentioned as one of the inspirations of actually thinking that they should put their lab here. Microsoft has also now said they're going to have 2 labs, one in Lagos and another one here in Nairobi. IBM Research has been here for a while, and we've also worked with them even this year at the Indaba. And that, again, starting from a group of people who are Africans going like, we should change the way that we view machine learning and AI on the continent. We can do this differently. We don't need to wait. And in a way, come together and build this thing. People will come on there, and now we have thousands. In a way, for organizations, encourage people to apply on there. For people who are interested, we're going to Tunisia, we're going to have these Indaba X's. We are looking for assistance, whether it's through encouraging people, whether it's through sponsorship, whether it's through finding good ways that we can partner. Come talk to me about that. And yeah, we want to advocate for a more connected community. For individuals, yeah, we have a Machine Learning and Data Science Africa network mailing list, over 2,000 people, where opportunities in machine learning are shared. People tell us about what they're doing in their spaces, and you can keep an eye out for Indaba announcements on there. And you can also keep track of conferences. We have a website for that, on machine learning that are based on the continent. And yeah, bring others into this conversation to mentees and potential mentors. For the Africa we want, and we need to have this legacy on that part. And as I said, to speak is not to do. Right, we must do. Right, that's the biggest thing that we need to do, because there are other people who are coming after us who need us to do these things in more ways than one. So thank you for that. And yes, it's not me. Like, I'm just just an extension of all these people I've been working with over the last 5 years. Yeah, I cannot emphasize that more than enough. And you can, if you take a picture of this, I think it'll give you my contact details in a way. And because I'm also an academic, these are some resources if you want to understand where we are from a more high-level view, where this is like covering up until the 3rd industrial revolution. And these two are these challenges that come with this data being in our world. And hopefully, if you're really interested in data science and bringing it into your work, then there's like 3 resources that I would suggest people actually then read. So thank you.